So we've had a couple of great talks so far. I'm going to try to reference back to them because I think there's great stuff to include from both talks into this. And I had no idea what was going to be before me, so we'll kind of try to weave those ends together. So I'm going to talk about Service Catalog, which is an extension to Kubernetes API. Stefan talked about CRDs and allowing you to define additional things, kind of use Kubernetes as a platform to deliver your APIs. Service Catalog is trying to do the same thing, predates CRDs a little bit. First about me, I work for the Microsoft Azure Containers team. I specifically work on something called Open Service Broker for Azure. It's an open source project. You can find it on GitHub under the Azure repo. I also worked on some upstream things in SIG Service Catalog, which is really about bringing services into your cluster, how you provision those things, how you manage and connect your applications to them. You can find me on Twitter. There's my Twitter handle, GitHub. And then if you have questions after this, I'll be at GopherCon all weekend, I guess. And you can also email me. Any of those venues are great ways to get a hold of me. So just to kind of set the state for what we're going to talk about. When you build applications, unless they're super trivial, there's going to be multiple things that make up that application, like in aggregate. You may have some stateless thing that's going to run really, really well on Kubernetes. You may also have something like a database, some NoSQL database that you need to store data into and fetch data from. You may also have some other stateful service that you need to run. It could be like Elasticsearch, could be any other like abstraction that's going to end up having some sort of state that you want to either run or connect your application to. When you build up bigger microservice-based systems, this gets even more complicated, as each one of those little things ends up having some sort of persistent piece, some sort of stateful piece that goes along with it. So if you were going to build this example online web store, this comes from a Spring advocate or a Spring developer advocate named Kenny Bastani. This is like a simple service that's doing an online web store, but it's built up from these multiple microservices. In this case, they're all Java-based, but each one of them is a little microservice that may or may not use the same sort of persistence. Like in this example, there's a MySQL, there's a Neo4j, and a MongoDB. So you're using like polyglot persistence in this. Each one of these things is probably independently managed and deployed. So when you get into Kubernetes, like that becomes kind of a complicated picture. You have this kind of fork in the road. So those stateless things are super easy to deploy on Kubernetes. That's what Kubernetes does really, really well, right? It deploys stateless things that can come and go. You don't really care about what happens to them. They can scale out, scale in. Those are all really trivial things. Or you can run stateful things. So you could run that MySQL on the cluster. You could run something like etcd on the cluster. There's lots of trade-offs for that, though. So you have this fork. Do I run those things on the cluster, or do I want to run them outside of the cluster? Do I want to run them as a managed service, or consume them as a managed service? So if you take the first fork, which is running them on the cluster, you're in great company because according to the Kubernetes apps survey, around 25% of users are deploying some sort of stateful workload. Could be SQL databases, could be NoSQL databases, could be messaging queues like RabbitMQ. Lots of people are running, obviously, stateless things, though. So it's possible, and it's getting better and better. There's lots of things that make it a little bit easier. If you just want to deploy something very simple, there are Helm charts that will let you run like a single node MySQL or a single node Neo4j or Postgres. There are also Helm charts that will try to get you to the state where you can run highly available versions of these things. It's a little less great because you're really just deploying those things into Kubernetes. If it's something like Cockroach, maybe it's great. It can talk to the API server. It can manage those things about being highly available and keeping track of like the cluster itself, like outside of Kubernetes. Operators are making this even better, and they're using custom resource definition. So you can say like, I want to make an etcd cluster. So the etcd operator was one of the first things that was kind of implementing this pattern. It allows you to say, I'm going to create this etcd operator. It's going to create a custom resource definition that defines what an etcd cluster looks like. And then you can say, please create me an etcd cluster. And it has two pieces. One, it's going to go create that resource. And then the control loop that Stefan talked about, that goes along with the operator. It's just general. It's a very specific control loop. It's going to manage the lifecycle of that thing on the cluster. So those are all great. But you can still run into problems. Data persistence has gotten a lot better. Persistent volumes work really, really well. But you can still run into these states where like, I have to back those things up. They go away. Kubernetes itself is pretty hard to run. You're adding like extra complexity on top of that once you start running these stateful things. So if you go the other direction, a lot of people also take that path. So there was this really great thread in February, I think, from Kelsey Hightower. It had tons and tons of responses. There's like, at this point when I like screenshotted this, there were 24 responses, but it got bigger and bigger and bigger. But his thesis was that Kubernetes has made really great improvements in running stateful things. But he still doesn't like to use Kubernetes for running stateful things. He gives some good examples why. It only meets you halfway for running stateful things, right? Like it can run your pods, basically. When it gets down to it, you're running pods for MySQL or for Postgres. But if you need to run those things in a highly available cluster, it doesn't know how to tell those things where to find each other. Those things have to know how to build like their actual cluster up. So they're exchanging data, doing those things. Kubernetes doesn't provide that to you unless you know how to consume those things from the API server. Cockroach, Consul have come along to understand how to run better in that environment, but a lot of things don't. MySQL is not great. MariaDB, not great. They don't have that kind of logic built into them. My previous job, we built a service that was running, it was persistent, running inside of Kubernetes, and we had to consume the API server and find the other pods that made up our deployment so that we could talk directly to them instead of going through the services. It just added a lot of extra complexity into the application. So his response to this whole picture is to either isolate those things into stateful sets on dedicated nodes that you don't have to worry about sharing resources with. You can predict them much better, or run them as managed services. And the takeaway was Kubernetes supports stateful workloads, but he doesn't. So if you want to do that, what's the logical next step for that? Do you have all these great Kubernetes ways of defining what your application looks like, what the service that's going to expose that thing looks like, how many replicas, all of that great information, those are all codified in Kubernetes. You could build a custom resource definition to do that, build a controller to go handle that. You could use CloudFormation or Azure Resource Manager or Google Cloud Deployment Manager or Terraform to define what those things look like and run and control them outside of Kubernetes, and then figure out how to get the credentials back into the cluster so your application can use it. But that's kind of painful. And again, it's giving you more work to do. The great thing would be is if you, as the operator of the cluster or the user of the cluster, could say, hey, please create me this service. Give me a spanner that I can then use, or give me an RDS instance that I can just use for my application. And then I deploy my service and I say, hey, service, go use this thing. That would be great. You wouldn't have any kind of, you wouldn't have to sidestep out of your normal Kubernetes operations. You wouldn't have to learn a lot of new tooling if you're a developer. It would just be part of your normal workflow. So there's two things that really make this possible. The first is the Open Service Broker API. So this was a concept that was in Cloud Foundry. So if anybody is a Cloud Foundry user, this is just a concept that's been there forever. And really what it does is introduce a couple of verbs and nouns that are going to allow you to define how to use those services in an abstract-ish kind of way. So the first of those is a catalog. So the catalog is the thing that implements the OSB API can define a catalog of the things that it provides. So if you're Google or Amazon or Azure, you can say, we provide SQL database, SQL server. We provide something called Cosmos DB, or we're Google, we provide Spanner. Those things are then available via the Open Service Broker API. And as a consumer of that API, you can say, please provision me one of those things. In an abstract way, provision can really be like, go make me something and go create all the infrastructure that makes that thing up. Or it could be make me a new tenant in something that's multi-tenant. Once that's done, you have a record of that thing, and then you can bind to that thing. And the binding operation is really telling the broker to go do whatever magic is necessary to give me back a set of credentials to access that thing. If it's a single tenant system, it could just be like regurgitating those credentials for me. If it's a multi-tenant thing, it could be making me a new user inside of that new tenant and returning that information back. Obviously, during the lifecycle of that thing, you may need to update it, like change the firewall rules or change the replicas. Like maybe I want to replicate this thing into Europe and the US, and I didn't do that when I provisioned it originally. Those operations are going to allow you to go say, make the changes necessary in the back end, and make that happen. Unbinding is the inverse of bind. So once you no longer need those credentials, go ahead and get rid of them. And then deprovision is clean up that thing. So just go either remove the tenant, remove all of the backing infrastructure, whatever makes that possible. Okay, so we have this great API that defines all these common abstractions. How do you integrate that into Kubernetes? So Kubernetes doesn't have any of these things as default API resources. It's not in the core API like a pod or service would be. So what happened is something called Service Catalog was built. And Service Catalog predates all the work that's happening with CRDs right now. So in the chart that Stefan had earlier, on the very left side was something called the API aggregator. What that allows you to do is to build basically your own API server and then register it with Kubernetes so that when a resource comes in, it can say, do any of my aggregation servers satisfy that? And that's what Service Catalog does. And Service Catalog provides a couple of extra resources that are going to map to that open service broker API and allow you to, just like you would with CRDs, allow you to create those things using the spec and status flow that fits into Kubernetes naturally. So first of those is a cluster service broker. So you define a spec for what that cluster service broker is, like the URL that it's going to be available at, whatever credentials, like maybe a JOT, a JSON Web Token, or username and password. And then you register that with Service Catalog. And Service Catalog then says, grab all of the catalog information from that and return it to the cluster and make a couple of new resources. So those things are going to be the service class. And that's going to be, the naming kind of sucks, but it's, the service class is like MySQL, not the class of MySQL or Postgres. And then within each one of those classes, you're going to have levels of that. So it could be, and those will be service plans. And that could be something like the free version of MySQL or the super, super expensive version of MySQL. The free version of SQL Server, the super, super replicated in like 19 geographies SQL Server that's thousands of dollars a month. The combination of those things is going to allow you to identify a given instance that you want to come into fruition. Inside of that, you're also going to be able to specify what parameters you want. So sort of like in the CRD where you could specify the validation rules, like it's going to have allowed values, or it's got to be only ASCII instead of Unicode. This allows you to actually specify what the parameters are so that nice UIs like OpenShift can dynamically build you up like a GUI workflow for building these things out. So in this case, it's using the Azure broker, and we define a schema that says each one of these instances can have firewall rules. And inside of the firewall rule is IP address, a name, or an end IP address, a name, and a start IP address. And these are all defined as JSON schema. So like Stefan mentioned in the CRD validations, those are Open API, which is really similar to JSON schema. These are actually using JSON schema. Inside of each one of those plans that was created in the previous step, you have the ability to provide different JSON schemas. So if you're building a broker that you want to expose to Service Catalog, each one of those plans has different options. You can expose those things all to the end user via JSON schema. So that's great. You have the service plan and the class. You know the parameters that are necessary to make that thing. So the next resource that Service Catalog adds is the service instance. And the service instance is really going to apply that spec and status to building your thing in the cloud or wherever. Inside of the spec, you're going to specify whatever parameters are necessary for that. So in the previous screen, we had the text boxes for firewall rules. It's going to put those things into the spec, and then the controller for Service Catalog, once you post the service instance back, is going to say, okay, I know that I need to take this service class and this service plan and these properties that are in the spec and turn that into whatever operations are necessary to go provision this thing. And that's really all Service Catalog cares about. It's going to delegate all of that to the broker. The broker is going to go and take care of doing those individual things. All the major clouds have a broker. So we have one, Google has one. For Amazon, there's something called the automation broker. It's a Red Hat product that uses Ansible to do those sort of things. So you can build these things in really flexible ways to do what you need to. You can build your own broker if you have some complicated scenario that you want to use. So once the service instance is posted to Service Catalog, there's going to be a reconciliation loop that happens with normal controller kind of workflow. Once that's done, the status will get updated with whether it failed or whether it passed, whatever other information is going to be populated into that. and it's available for you to use for binding. So the last really big concept from Open API or Open Service Broker API is service binding. And the service binding is how you say that I want to connect my application to this thing that was provisioned via the broker. And inside of that, you reference the service instance you want to use. So in the previous example, we might have named it MySQL talk instance. And in the binding spec, we say we want to use MySQL talk instance. If there are parameters that are necessary for binding, it could be like SSL certificates or whatever other information, you can include that as well. Just like you can do for provisioning, you can specify JSON schema for bindings as well. And then once you do that, you post that back. What actually happens is a secret gets created. So the kind of normal way for storing sensitive information in Kubernetes is to use a secret, and that's what service catalog does. In that secret, it's going to be kind of up to the broker to specify what that looks like, but it's generally going to have something like the URI to connect to, the username, the password, any SSL certificates that are that you need for mutual TLS. All those things are going to get written into a secret, and then you can just use it from your application like you would in any other kind of Kubernetes native way. So there's a couple of things that Service Catalog doesn't do right now that make it a little painful to use. So one of those is you actually have to know the class and the plan to make something. So it's not as simple as saying, please make me a MySQL or please make me a Postgres. You have to know the very specific naming. So like in the Azure case, it's Azure Postgres, and then it's general purpose or memory optimized as the plan names. So it's not super portable between cloud providers. As the operator of the cluster, that's probably cool, right? Like I want to know exactly what's going to be built. Maybe I have access to the AWS keys and I only want to allow certain things to be created. But as the application developer, I probably don't care. I just want a MySQL or a Postgres or something that looks like that to be created for me. So Service Catalog doesn't do that now, but it's going to be addressed through something called dynamic templating. You'll be able to specify a template, kind of like a CRD, that looks like this is creating something called MySQL, and you're filling in the pieces behind that, and then it's just available for somebody to say, please create me MySQL as the class and plan name, and it will figure out what those things look like. Classes and plans and brokers right now are cluster scoped, so you can't really do real role-based access on those things. So you can either say someone has permission to create a resource, like a service instance or a binding, or they don't. You can't say that you can create a free one, but you can create the super expensive one. You don't have that kind of level of granularity. Kubernetes just doesn't really support that. It supports that at the namespace level, but not really at the cluster level. So what's going to happen is Service Catalog is going to introduce namespace versions of the brokers and the service classes and plans. So you'll be able to register the broker in a specific namespace and then filter or whitelist out which plans are available. So then me, as the user of some super constrained namespace, can say, just please provision me this one plan that I see. In the end, what you're really doing is using normal Kubernetes tooling like kubectl to create that Postgres instance or create whatever that thing is. That extends to using other Kubernetes tooling. So Helm, as an example, I can use Helm with Service Catalog to define a deployable thing, like my application, that will also go and deploy MySQL for me or use a MySQL that already exists. And I'll do a couple of demonstrations of that right now just so you can see what that kind of looks like. One other thing that's in the future that I forgot to mention on that slide is that Service Catalog right now is an API, an aggregated API server. It's going to be rewritten as CRDs. It existed before CRDs were really a thing. The initial version of Service Catalog actually used third-party resources, and that didn't work so well. So the thing that we moved to was, like, that was going to be the next big thing was aggregated APIs. There's a little bit of pain that comes along with building an aggregated API server. So CRDs are where I think everybody's going to kind of end up, and that's where we're definitely going to end up. OK, so I have a couple of clusters that we're going to take a look at really quick. So I do kubectl API versions. Oh, wrong screen, because I'm doing a, doing the slideshow still. OK. Come on. Didn't. OK, we'll just do it from this one. For whatever reason, that other terminal stopped working. Okay, so if I do kubectl, I mentioned one of the resources that we create is cluster service brokers. So I could do get cluster service brokers. And here I have 2 service brokers registered, Minikube and OSBA. So that means that I have service catalog running. And if I do get pods, I've installed it in the namespace catalog. You can see that there is the API server. So that's the bits that's getting the delegation from the big top-level Kubernetes API server, and then also the controller manager, which is implementing all of those logic loops. If I switch to another cluster, like use config, this other one that I used before, if I do the same operation, there's nothing registered. It'll take a second because it's got to go through all of its things to find a resource. It doesn't have that resource. So I can register one. I'm going to use Helm to install it. So there's a bunch of things that make up what you need to install an aggregated API server. It's way harder than doing a CRD. You have to generate SSL certificates so that those 2 API servers can talk to each other. You have to define the pod that thing's going to run on. Could be multiple controllers. You have to define the service that's going to expose it. So we package all of that in Helm, and that's kind of the recommended way for installing service catalog. Inside of this Helm chart, so Helm is kind of like a package manager for Kubernetes. So these are the things that we define. Here's the API service extension. Here's the service accounts that we're going to create, the pod, the secret, the persistent volume claims, the service, and the deployment. And that's going to include that I do get pods from the catalog namespace. You can see this thing actually has 2 pods, this API server. Inside of that, we're running a on-cluster etcd instance because as an aggregated API server, you don't get direct access by default to the etcd that the API server is running in. So it's bringing along its own etcd server to the party. So this will take a little bit of time to get up and running, but you can see those are the things that it creates. It's fairly complicated. It's creating a secret with the certs stuck inside of it. It takes a little while for that to come up. So we're going to switch back to my other cluster now. Okay, so again, we have cluster service brokers registered. The 2 that I have are the open service broker for Azure and then mini broker. So this is just kind of showing you that you can register multiple brokers and work with them in the same way. So the next thing I can do is get cluster service classes. And you notice in both of those cases that it's not really giving me friendly output. That's another kind of downside of aggregated APIs. You have to build all of the stuff into Kubernetes API, like into your API server, to handle kubectl outputting things that you'll get by default with CRDs and the new version of CRDs. You can use custom columns when you're doing this outputting and stuff. We actually built a domain-specific tool that does this because it's kind of a pain to use. So you do get classes using this tool called svcat. Okay, so you can see there's a bunch of things registered. I've got all these Azure services. Those are obviously coming from the open service broker for Azure. And then mini broker, what it actually does behind the scenes is use Helm to install those things for you. So it's not something you want to use in production, but it creates a new tiller for Helm, which is like the thing that Helm uses inside of your cluster in a private namespace. So it's not really exposed to you, but you can use all the things that are exposed as Helm charts already, like MariaDB, MongoDB, MySQL, Postgres, Redis. There's a whole bunch of other ones. Instead of having to learn Helm, you're just going to use the normal service catalog thing. Same thing for plans. And there's tons of information that comes back with each one of these things, like the name, the class, the description. These can be as long as you want. And then the UUID is like the unique identifier for it. Okay, so those things are all cluster level. You can do the same. You can use the same kind of tooling for getting instances. So if we do get instances, we'll use the namespace Tweety. I have a Cosmos DB instance running. Its class is Azure Cosmos DB Mongo account. The plan is account, and the status is ready. I can describe it. So all these things that you can do with svcat, you can do with kubectl. This is just a little easier. So you can do describe, just like you do kubectl describe. We'll do Cosmos DB in the namespace Tweety. Oops. So this is it's changing the output for you a little bit, so it's a little easier to consume. So you can see what the parameters are. It'll do some traversal to find out if there are any bindings associated with it. And then if you want to look at what it actually looks like, do kubectl get instances, service instances. Type service instances. So there's the output. You can do the same kind of thing you would with any kubectl command. Cosmos DB. Okay, so we can do a describe on that, just like you would use svcat. And you get back that bigger block of data. And this is going to show you that kind of spec and status thing. So in the spec for that, we've defined what the parameters are. So we've got IP filters, allow access for Azure, the allowed ranges, the locations, we want to run it in West Europe, what resource group in Azure we want to use. And then like the really important things are which plan. So we have this external plan name and this external, or sorry, the external class name and the external plan name. We've resolved those into references inside of the spec. So service catalog kind of takes away the need for you to know those UUIDs and just makes it work for you. The status, you can see whether it's in progress, no, and then the conditions associated with it. It was provisioned successfully, it's ready to use. And so that's a thing that exists. If I go to the Azure portal, we'll see that Cosmos DB instance exists. When I created it, I used the namespace as the resource group to use in Azure. Look in Azure Cosmos DB, and I go to resource groups. I've got Tweety. And it's got some long UUID because that's what the broker generated. But I didn't have to go to the portal to do that. It was just created as part of a normal Kubernetes operation. And what that looks like if you're going to provision it, something like this. So I've defined all of those things inside of a Helm chart. Look at what Cosmos DB looks like. So inside of this, I have one YAML file, essentially. It's a MongoDB instance. And it looks just like any other YAML file you would have for any normal Kubernetes resource. The API version is servicecatalog.k8s.io/v1beta1. The kind is service instance. And that's what we saw when we were using the command line. And then it's templated, which this is normal Helm things. But I'm going to explicitly say that I want Azure Cosmos DB Mongo account, the plan account, and then some properties that we want to feed into it. So if I run a Helm install on that, Cosmos DB, and just put it in the Kate's Meetup namespace. So it went to the server and said, please create that for me. Now if I do a kubectl describe service instance Cosmos DB, which is the same thing that we created for the other namespace here. May not have created it yet. Oh, I named it the wrong thing, so it's in default. Sorry. So there it is in the default namespace. So if I do describe on that one, okay, describe service instance DB. Okay, sorry. In this, you can see that the status is different. The asynchronous operation is in progress. You have some status that's being updated by service catalog from the control loop. It's being provisioned asynchronously. It's not ready to use. So it's another instance, and eventually it'll show up in the Azure portal. May not be there yet. Wrong namespace. So in the default namespace, there's one. It's currently creating. So I didn't have to go to the portal to do that. I didn't have to use Azure Resource Manager, which is like our version of CloudFormation. I just used normal Kubernetes tooling to make that happen. So it exists. It will exist and be ready to use later on. The other cool thing I can do is that once that service instance is available, I can use Helm again to create a new service. So I'm going to use this. I'm going to create something that, oops, wrong directory. I'm going to create an application that's got two containers in a pod that's going to use that Cosmos instance. It's use the MongoDB API on that Cosmos instance. And it's going to wait for that instance to be created. So if I go into this directory tweet scraper and I run this, put it in the default namespace. Now it should work. Whatever. I'll just run this whole command. Should. Yeah. Yeah, that's probably, I probably misspelled it in the bash script too. Yeah, I did, yeah. So I made a bash script that sets those things for me as environment variables, and I spelled terribly. So what this Helm chart did was create the service instance itself. So it's going to go create another one inside of this namespace. It's going to create a binding on that when it's ready. We do use svcat, we can look. It's creating one, it's provisioning. If I look for the bindings on that, it's not ready yet. So I've defined, do a k get service binding, this. Sorry, describe. In the spec, you can see that we referenced an instance ID. Again, service catalog did the resolution for that. I said I want Cosmos DB. It figured out what the UUID for that was. And the control loop inside of service catalog is going to keep looking at that. So when that service instance becomes ready to use, it's watching that resource that it's depending on. It'll be able to go then create the binding and make it ready to use. So that service, that's all deploying. I made one before this because it takes a little while for that to happen. We look inside of the Tweety namespace. That one's deployed already. And if I do the same thing for bindings, there's a binding ready to use. You can do scribe on that. One cool thing we added into svcat was the ability to show secrets. Binding. So it's going to dump out all of the stuff that was created. So our broker is returning connection string, it's returning host, password, port, URI, username, different ways of accessing that same data. That's inside of the secret that's going to be created. So in the spec, we specified what we wanted the secret to be, and that's the resulting thing that comes with it. And then for my pods, got this thing. So if I describe it, you can see inside of my definition, I said, please use the access to, or sorry, the host, port, username, and password from that secret that's going to be created. I bundled this all up in the Helm chart so that it's really easy to use. I look in the templates. I define the binding, the deployment, and the service inside of this. So I've got the Cosmos DB binding, and that's going to reference some sort of instance, which is like a parameter that I passed in, defaults to Cosmos DB, and then I specified a secret name. So that's the spec that was defined for that service binding, and then the end result really is that whatever you define the secret name here, that secret will be created. And then in the deployment, you can say, using normal Kubernetes conventions, like I want to create a Mongo host, Mongo port, Mongo user, Mongo password. That's what my code's looking for, and then populate it with that secret that was created as part of the binding process. So that's running, and if we look inside of the database, what it's doing is looking at the GopherCon Iceland hashtag on Google or on Twitter, and then populating the database with that. There'd be a few in here. It's not like the most active thing in the world, but I can also then say I want to expose this guy. Okay, so I'm port forwarding to that, and now I can grab data from it. So there's two things that are in that pod. One is the container that's running and scraping Twitter, sticking them into Cosmos DB. The other one's a REST API that's reading from Cosmos DB. So simple, makes Clippy from Microsoft. So it's just randomly grabbing, randomly-ish grabbing tweets from Cosmos DB using Mongo, spitting them back out. So I was able to write this application and not worry about how, like, I did it because I was one person doing the presentation, but like in the real world, I could have whoever is the operator of my cluster worry about standing up that Cosmos DB instance or MongoDB, whatever, and then I can just work on building my application. So we have like an agreed upon set of environment variables that we're going to use in our application. We know that there's a secret that's going to have those. Cool. Some of the other cool things that are in Service Catalog that exist today is the ability to do secret transformation. So like one of the kind of annoying things between different brokers is there's no spec that says what the secret has to look like, what things come back in the credential. So the Google broker could have this crazy long nested set of parameters or information that come back in the binding, whereas we have like a really flat one. So it's not really portable, right? Like if I'm going to provision a service on Azure, and then later I want to go provision the same thing on Google, like I have to know those differences. Service Catalog allows you to, inside of the binding, to actually specify what those things, those transforms look like. So in another chart here, okay, so in charts, I have this other one called MongoDB. So Cosmos provides a Mongo interface, but you could also install MongoDB using MiniBroker. Inside of the templates, we're defining two things, the instance and the binding. And in the instance, I'm using conditionals inside of the Helm chart. So Helm's really great. You can do all kinds of crazy templating things like use Go templates. So inside of the spec, I can say if values.instance .local is not set, then use cluster service class external name Azure Cosmos. Otherwise, use MongoDB. So like as a cluster operator, I know which one of those things are available. And then me as the, putting my other hat on, me as the application developer, I can just include this MongoDB chart in my application. And when I provision it, I don't know that needs to be set, and I'm just testing this locally. I can just say, install my application that uses this chart, and it's going to go ahead and create a MongoDB instance on the cluster for me. If I'm deploying it into production, I can say that it's a local, it's not local. Deploy the one in the cloud. So then the obvious kind of like follow on to that is the binding. Same principle. If it's a local instance, I'm going to apply this transformation. So I'm going to rename the URI key into connection string. So this is a really simple one, but you can do more complicated things. In the MongoDB thing, if you install MongoDB with Helm, the secret that gets created is really URI. So there's a URI that gets created in that secret, but I know my code is expecting connection string as the key inside of that secret. So I can do that transformation inside of here. You can also remove things, add things, like if there's certain information that you know the broker returns that you don't want, you can use the remove. If you want to add things from other secrets and kind of combine them into one big thing to use, you can use the add functionality. So a lot of improvements are being added or have been added to kind of make the user experience better for Service Catalog. Okay, so if you want to know more, two places you can go. Come on. So the first and the easiest thing to do is to go to svc-cat.io. And this is going to give you just a website that gives you quick links to like how to get started with it, how to install it, some overview data. You can also go to Kubernetes Incubator on GitHub. So github.com/Kubernetes Incubator. Service Catalog is one of the first things that's in the Kubernetes Incubator. And then you can look at all the code. You can see how to implement your own aggregated API server if you want. You don't want to use CRDs. We're also on Slack, on the Kubernetes Slack. So there's a Service Catalog channel. If you have questions and you want to know more, ask questions, suggest things, that Slack channel is a great place. It's monitored by all the major parties that are involved. Open up issues if you want to look at issues, if you want to contribute to anything. It's in active development right now. There's lots of opportunities for people to jump in and help. Cool, so that was all I had. I'll open it up for questions now if anybody has anything. Yep. 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 Yeah, so you say, I'm going to create this service binding. And you're creating that in a desired state. And Service Catalog's control loop says, I've received this binding. I need to go look in the spec to find what the secret name is. I'm going to create that secret and populate it with whatever information came back from the broker when I issued that bind operation. So Service Catalog says, OK, I've received that binding request. I'm going to go to the broker, make whatever the bind call is. That's going to return some data. I'm going to put that into the secret. The binding is created, or the secret is created by the controller. So you say kubectl create bind or create service binding, or kubectl create -f with that YAML file. Service Catalog is going to create that secret into the namespace that you specified. It's up to you to wire the secret into your application, just like any other secret would be. It's not going to give you it's not going to give you the ability to like automatically say, take the secret and build these environment variables. And that's another thing that's on the roadmap of cool things to add for user experience. In Cloud Foundry, that happens for you automatically. When you say, like, I want to bind to this service, it builds up a set of environment variables for you automatically. It's really prescriptive. And it's called VCAP services. And inside of that, there's a very specific format for what that looks like. And that's available to your application. And you as a Cloud Foundry person know that that's what it's going to look like. Kubernetes is not really that prescriptive. So what you'll be able to do is define really a mapping. So you know that your application is looking for a certain number of things. It's looking for Mongo, like back in my my deployment spec in that other chart. In here, I know that my application is looking for Mongo host, Mongo port, Mongo user. Oh, sorry, stupid PowerPoint again. Now it'll take a second for it to come back. Okay, so when I wrote my pod spec here, like my deployment inside of the container spec, I know that I'm looking for Mongo host, Mongo port, Mongo user, Mongo password. And I know that I'm going to map those things from this secret that gets created as part of that process. Like one of the cool things that'll be added to Service Catalog is like in the backlog is the ability for you to create another resource. This will probably happen like as part of that move to CRDs. You'll be able to say, given the secret that's generated automatically, using some like a mutating webhook, modify that thing so that it automatically will stick this in for me. So you won't have to build this part out yourself. Yep. So in the binding, in the spec, yeah, in the spec you're saying, here's the instance to use, but the thing that you're keying them together with is a secret name. So you're saying this binding should result in a secret named whatever that is. Yep. All right. If there are no more questions, thanks so much. If you do have questions, like I said, you can email me, find me on Twitter, or I'll be around GopherCon all weekend. Thanks.